Hello everyone, welcome back to the channel. In today's lesson we are going to study subsets, properties of subsets, power sets, and formulas related to the number of subsets. Also, we will solve several examples step by step. Let's start with the definition of subset. Let A and B be two sets. A, B are two sets. If every element of A is also an element of a set B, then A is called a subset of B. Let me write this. This relation is denoted by A as a subset of B, and mathematically we can define this as for all x in A implies x in B, which means for all x in A implies x is an element of B. So this is a mathematical definition of a subset. If A is a subset of B and A is different than B, then A is called a proper subset of B. And this is written as A is a proper subset of B. If there exists at least one element of A that does not belong to B, then A is not a subset of B. And we write it as A is not a subset of B. Let me repeat it. If there exists at least one element which is an element of A and does not belong to B, then A is not a subset of B. Or we can write it. Let's solve an example. First example. Consider the sets A contains 1 and 2, set B contains 1, 2, 3, and set C contains 1, 2, 3, 5, and 7. Since every element of A belongs to both B and C, we can see that elements of A which are 1 and 2 both belongs to B and set C. Since every element of A belongs to both B and C, we obtain that A is a subset of B and A is a subset of C. Similarly, every element of B, you can see that every element of B belongs to C. Hence, B is a subset of C. Hence, the inclusion relation among the sets is A is a subset of B and it is a subset of set C. Or equivalently, let's write second example. Example 2. We are given a set A which contains x's such that x is between 0 and 6. Also, x is a natural number. And we have a set B which contains 1, 3, and 5. First, we write set A explicitly. If we write set A, we can see that A contains 1, 2, 3, 4, and 5. So, every element of B belongs to A. So, we can conclude that B is a subset of A, or equivalently, we can write it like this. Now let's see some properties of subsets. The first property is every set is a subset of itself. In other words, A is a subset of A. The second property is the empty set is a subset of every set. You can check our previous video for the formal definition of empty set. We can write this as empty set is a subset of A. Okay. The third property is if A is a subset of B and B is a subset of C, then we can conclude that A is a subset of C. This property is called transitive property. Okay, now let's see a power set. The set consisting of all subsets of a set A is called the power set of A. Let's write this definition. And it is denoted by P of A. Okay, let's write an example. We'll continue with example 3. Let's write all subsets of the following sets. A. If A is an empty set. The empty set has exactly one subset, and it is itself. So P of A is a set which contains empty set. Because we know that empty set is a subset of every element. Here our set is empty set, which we can conclude that it is a subset of itself. For part B, we have a set B. It contains an element A. We know that empty set is a subset of B. Here also set A, in other words, B itself is a subset of set B. Hence, our PB is a set which contains empty set and set A. Let's continue with part C. In part C, we have given a set C which contains elements A and B. Here, we know that empty set is a subset of C. Also, a set which contains only an element A is a subset of C, as well as we can write B. Lastly, we know that set AB is a subset of C. So, finally, we'll have P of C, which contains empty set which contains A, set which contains B, and a set which contains A and B. So our P of C has 4 elements. And let's continue with part D. In part D, we are given a set D which contains 3 elements, A, B, and C. So let's write the subsets of D. First of all, empty set is a subset of D. And we can have a set which contains only one element. In other words, set A, set B, and set which contains C. These are all subsets of D. And we can have AB as a subset of D. Also, AC is a subset of D. And BC is a subset of D. Now, we have already done subset which contains 0 element, which contains 1 element, which contains 2 elements. Now, we will write a subset which contains 3 elements, which is D itself. A, B, C is subset of a set D. Now, we will have an intuition about a number of subsets. If a finite set contains an element, then number of all subsets is given by cardinality of PA equals to 2 to the power of n. Here, S of A equals n. Let's write it properly. Now let's continue with examples. Example 4. We will determine the number of subsets of the set A, which is given as A contains x such that x is between 0 and 18. Also, x is a prime. So, we are looking for primes less than 18, which are 2, 3, 5, 7, 11, 13, and 17. Thus, our set A is a set which contains these primes, and S of A equal to 7. Therefore, the number of subsets is equal to 128. Let's write another example. Okay, in our example, it asks that the set has 512 subsets. Determine the number of elements of the set. We write the number of subsets as 2 to the n. It's given as 512. 2 to the n equals 512. Since 512 is 2 to the 9, we know that n equals to 9. Hence, the set contains 9 elements. So, today we studied subset relations, proper subsets, power sets, properties of subsets, and formulas concerning the number of subsets. We also solved many important examples using formal mathematical reasoning. If you enjoyed this lesson, don't forget to like the video, subscribe to the channel, and see you in the next mathematics lesson. Thank you.